So today we are reviewing methods. Methods are really good for several reasons in Java. One is to organize your code based on functionality, right? So for example, if I have a lot of code and it's doing one specific purpose, such as computing the average of some numbers, right? I can do that in my main method, no problem. However, to organize my code better, it probably would benefit me to put it in a method, right? Not only that, it also makes our code reusable. Instead of having to rewrite all of that code, we just call our method, right? And each method has a signature. And using that signature, you can call your method. So let's create our first program, Java with Maven Java application. We can call this review 4. And I guess I just called it review. All right. New, I'm going to make a main class. I'm just going to call it app again. All right. So this whole time, we've been using a method in our programs. It's called the main method. And it's the first method that is run by the Java JVM when you run your program. Right? It always searches for your main method. And the signature never changes for the main. Public, static, void, main, string, brace, brace, args. That signature never changes for your main method. All right, we're going to have other methods throughout this class with different signatures. However, the main method never changes. Okay. Public, that is a Java keyword that makes it accessible in all of your packages. Right. So now we're getting into packages, organizing our programs. And when we use the Java visualizer or even JGrasp, if you remember that, we weren't necessarily using packages. It was just a class and that was it. Well, with packages, we have visibility. The public keyword makes whatever this method is visible in all of your different packages, right? If I import this class, I can use the main method. Static makes the method resident in memory. And by that, I mean, it doesn't change no matter how many times you call this method. It's going to be the same method in memory. If we don't have this static keyword, when we call a method, it's instantiated in memory. Once we finish that method, it goes away. The static keyword forces that method to stay and reside in memory. And going forward, we're going to have static variables. Those static variables, the values of those variables do not change no matter what class we're in. If we change it in one class, it's going to change in another class. If we change it in one object, it's going to change it for another object. And we'll talk about that later on as we get into the meat and potatoes of this class. So the void is our return type. The main method doesn't return anything. When you get to the bottom of the method, it returns nothing. It just ends. In other methods, we'll return integers, we'll return doubles, we'll return strings. Those are the main ones. We'll also return objects later on. The main method, again, only returns nothing. So the return type is void. The name of our method is main. That's why we call it the main method. Then it has one parameter, which is a string array named args. And these are the arguments that you pass in from the console. So if you run this program from the console, which may sound foreign to you all, because typically we just point and click to run programs. If you do a lot of Ubuntu or Linux, you'll be familiar with running programs from the console and passing in arguments. Well, this is how we read those arguments into our program. All right, again, we have our main method. I'm going to go over the assignment because that's going to feed into our methods discussion. So the assignment was to write a program that allows a user to convert our temperatures from Fahrenheit to Celsius, Celsius to Fahrenheit, Celsius to Kelvin, or Kelvin to Celsius, right? And again, I didn't explain this earlier, but I have extended the assignment until tonight at 11:59 p.m. You can submit either a NetBeans project or Java Visualizer URL, either one. I've opened it again. I've extended it until tonight at 11:59 p.m. So this will assist you in making that program. All right. So we want to read in user input. Depending on their input, we want to either convert from Fahrenheit to Celsius, Celsius to Fahrenheit, yada, yada, yada. Okay. So any of those four. So the first thing is we want to prompt the user to enter in their choice. System.out.println 0 Fahrenheit to Celsius. Oh, gotta be able to spell. System.out.println 1 Celsius to Fahrenheit. Just a second. System.out.println Celsius to Kelvin. System.out.println Kelvin to Celsius. And do not expect this video to be up by today because I'm extending the assignment. So I recommend you all pay attention to what I'm doing. And then the last one is, which conversion would you like to make? Sorry, system.out again. Println. Which conversion would you like to do? All right. All right, so then they type in their conversion, right? And we want to read that in. So we have to create a scanner. Input equals new scanner. In order to do that, system.in, right? What is my issue with the scanner right now? What haven't I done?
You haven't imported it yet.
Yeah, you haven't imported yet.
Correct. What's the shortcut to import in NetBeans, out of curiosity?
The Control-Shift-I.
Yep. Control-Shift-I. That's how you import. That's a shortcut. Again, or you can click over here and hit add import for java.util.scanner. Either way. Control-Shift-I is a shortcut I like to use. All right. All right, so the next thing is we want to read in their choice. So int, and because it's a 0, 1, 2, or 3, an int is appropriate, right? We're not reading in decimal numbers yet. Once we read in the temperature, we do want to read in decimals because temperature could have decimal numbers. Int, I'm going to name this choice. Again, I will be looking at what you name your variables for your programs. That is important because when you write a program, typically it's as a group, or your program will be a part of a larger program. And so people will be reviewing your code and they don't want to look through and see variables that make 0 sense as to what you're doing. You know, you're converting temperatures and you have a variable called red. It literally makes no sense to your program, right? Choice, to me, that makes sense. Hopefully somebody who's reviewing my code would say, okay, that's obviously the user's choice. So you want to make it obvious what you're doing. Equals input dot, sorry, I want to convert this integer dot parseInt input dot next line. All right. So we've read in the user input, right? 0, 1, 2, or 3. The next step is we need to figure out what they typed in so that our program can respond accordingly, right? Now we can use an if statement, but I always recommend when you're doing user input like this, where they're just making a choice, use a switch statement. Switch on that user choice. Man. Case 0, what is the user wanting to do when they enter in a 0?
It was the Fahrenheit to Celsius.
Correct. So we need to read in the Fahrenheit and convert it to Celsius, right? So we read in the Fahrenheit, convert to Celsius. So double Fahrenheit equals double dot parse double input dot next line. All right. Double Celsius equals, and then we do the conversion. So Celsius is Fahrenheit minus 32 times 5.0 divided by 9.0. All right, let's see, what is my, oh, right here. All right, and then a break statement. Any questions about that?
Do you always need the break statement? Always?
Yes, because if not, it'll keep going through and evaluating each case. We don't want it to evaluate it. We want it to, case 0 is true, stop. All right. So the next one is case 0. On case 1, I'm sorry. Right? They want to convert from Celsius to Fahrenheit. But you'll see an interesting issue will arise when I try to do this. So we want to read into Celsius, convert to Fahrenheit. Double Celsius equals double dot parse double input dot next line. You see another issue. It says variable Celsius is already defined in the main method, meaning I've already defined this variable somewhere else. I defined it up here. When it says defined, it means that you've already said the type and then the name. You've defined it already. So interesting situation with switch statements is, even though you may not evaluate case 0, so choice might be 1, these variables are still initialized up here, right? It's the whole switch statement is evaluated together. So everything within these brackets are evaluated together. So if you initialize a variable in one case statement, then if you try to initialize it in another one, you're going to have an issue. Okay. So the way to address this is just initialize all your variables before your switch. So double Fahrenheit, double Celsius, right? And then you don't have to reinitialize them down here. You can just set them equal to something. Make sense? All right. So again, we can initialize our variables up here, which gets rid of that issue that we had, that error. Okay. So now we have to do our conversion. And I don't know these off the top of my head, so I'm looking at the assignment. So we're going to go Fahrenheit equals Celsius times 9.0 divided by 5.0 plus 32. Right. And I'm going to start going a little bit faster because, you know, we only have about 25 more minutes and I want to get to methods before we end. So the last thing I need is a double Kelvin. Again, I've extended your assignment until tonight. And you could do it either using NetBeans or the Java Visualizer. So they're trying to convert from Celsius to Kelvin. So we read in Celsius again. I'm not going to repeat that code. I'm just going to copy this. Kelvin equals Celsius plus 273.15. Break, and I'm forgetting my breaks. Case 3, Kelvin equals all of this stuff. Celsius equals Kelvin minus 273.15. Break. And I'm just going to add a default down here. System.out.println invalid input. If they put in something other than a 0, 1, 2, or 3, that's invalid input. All right. And each time I'm going to print this out. So I forgot that. System.out.println Fahrenheit degrees Fahrenheit is degrees Celsius. All right. I'm going to copy this a whole bunch of times and modify what it's saying each time. So here I'm going to put Celsius, degrees Celsius, degrees Fahrenheit. Here, degrees Celsius is blank degrees Kelvin. And then copy this again down here. Degrees Kelvin is blank Celsius, degrees Celsius. All right. Any questions about this code so far? All right, if I run this, that's my main class. Select. Again, the first time you run it, it's going to download a bunch of packages, which again, that plays into the Maven. Oh, it didn't download it all, so we're good. All right, so the first thing I want to do, I want to test this and see if I put in that number. It should say incorrect input or invalid input. Perfect. So it's working in that respect. All right, that went down to my default case right here, invalid input. I'll type in a 0. I didn't prompt the user, so I'm going to go back and do that. But let's say 86 degrees Fahrenheit. It's 30 degrees Celsius. And I'm going to redo that. I'm going to update that to prompt the user. Because right now you see it doesn't say anything. So the user doesn't know what to type in. .out.println. Please enter the value in Fahrenheit. All right, so that way the user knows what to type in. Copy that, paste it here. And instead of Fahrenheit, we're going to say Celsius. Again, we're going to say Celsius. And then down here, we're going to say Kelvin. Make our program more responsive. So you see last time I typed in a 0, it didn't say anything. This time, if I type in a 0, it should say, please enter degrees. Please enter the value in Fahrenheit, 86. Well, I did 0.86 is negative 17 degrees Celsius. Run this again. I'm gonna type in a 2, so Celsius to Kelvin, 50 degrees Celsius, 323.15 degrees Kelvin. All right. So you see, we just made a simple temperature conversion program. Right? Slap a GUI on this or graphical user interface, and you can have a calculator, easy calculator. User, type in a number, we'll convert the temperature for you. Right. And now you're seeing how we can make programs usable from a user standpoint. If I go outside and somebody asks me in the UK, what's the temperature outside? I have no idea what 34 degrees Fahrenheit is in Celsius. I type it into my program. I want to convert from Fahrenheit to Celsius. It's 34 degrees outside, Mr. UK person. It is 1 degree Celsius. All right, makes it easy. We're making functional programs now. Any questions about this so far?
Not yet.
All right, so let's get into the methods. Methods, again, are really good to make this program more portable, reusable, and to organize our code better. So if you look, this is all our main method. We have 60, maybe like 56 lines, 50 lines in our main method. And it's doing a lot of different things, right? We want to try to organize this a little better. All right, the first thing, really, you want your main method responsible for calling other methods. You don't want to do a whole lot of logic in your main method. So the first thing I'm going to do is make a method that takes in the user's choice, depending on what the user chooses, is going to do these different behaviors. So I'm just going to put all of this into a separate method. So exit out of that. And again, actually, I don't need these anymore. I just need the switch statement. So I actually can delete those. All right, so the main method, it prompts the user and reads in their choice. I'm going to create another method. We're going to make it public. Because I'm calling it directly from the main method, it has to be static. I'm not going to return anything because I'm just taking in the user choice. Chooser, int choice. All right, it's just taking in the user choice. Paste in our switch statement. So our one parameter is the user's choice. And depending on what the user chooses, we have different logical expressions we want to do. All right. Cool. All right. I'm going to assume that's okay. So one thing as well is we've created our scanner here. I want to reuse that scanner. Granted, I could keep creating new scanners. So in this method, I could create a scanner, input equals new scanner. And again, these all have scope. So when you create a variable, it has scope. This scanner up here has scope only within our main method. This scanner here has scope only within our chooser method. All right. The issue is we want to make our programs as efficient as possible. So reusing variables when we can. Scanners, you can reuse, and we'll get into something later on called pass by reference. So basically what I'm doing is I'm passing in the same scanner that I have here into this method. So I'm going to create another parameter that is a scanner object. And we pass in our scanner object into this method, and we reuse it here. Everybody with me so far, creating this new method? If you have questions and you don't want to ask it in class, send me an email. We can schedule some time outside of class to review all of this. Again, you need to have this as a solid foundation for going forward when we get into object-oriented programming. By the way, what are the 4 pillars of object-oriented programming? I'm literally, for the most part, going to ask you every class. Can anybody tell me at least one pillar?
Polymorphism.
Polymorphism is one, correct. Anybody else? All right, that's fine until we start getting into it. The 4 pillars in alphabetical order are abstraction, encapsulation, inheritance, and polymorphism. All right, I need you all to lock that in because that's pretty much what this whole class is about. All right, so we have our method. Let's create a method for each one of these equations. Again, we want to organize our code, make it look cleaner. So let's start with Fahrenheit to Celsius. Public, static. Right now I'm going to do, let's see, what should I do? Let's do void. It's not going to return anything. Fahrenheit to Celsius. All right. No parameters. Actually, one parameter. It's going to be a scanner object. Scanner input. Again, naming is important. You see here, I use camel case, meaning the first word is lowercase. Each subsequent word is capitalized. I will start taking off if you don't have the proper formatting for your program. Okay. So inside this method, all I want to do is read this stuff in and print it out. So double Fahrenheit, double Celsius. Cool. That's one method. Let's make another method to do the opposite. Public, static, void, Celsius to Fahrenheit. Scanner input. Again, I'm passing in that scanner object so I can reuse it. All of this code is going to go into this method. I do have to reinitialize these variables because they only have scope, again, visibility inside this method. All right. Another method, public static void Celsius to Kelvin, scanner input. Let's take this code up here, cut, paste. Double Celsius, double Kelvin. Our last method, public static void Kelvin to Celsius. Scanner input. We cut and paste this down here. And now we have all of our methods. Double, double. All right. So we just created 5 new methods. From all the code we had before, we have 5 new methods. Okay. And you see, again, I'm going to take off for formatting. You see this line is indented here, and these lines are indented by 2. That doesn't look good from a programming perspective. So again, NetBeans has a nice feature. If you go to refactor, I believe, and let's see, where is it? Every IDE has it in different places. So source, it might be in source, fixed code. No, it's not fixed code. Source. No, not fixed code. There's an auto formatter I'm trying to find. Let's see. Oh, it was the first one. Format. So source format, and you see it fixes those indentation errors. Okay. So this was my code before. You see it's indented differently, which doesn't look good. Source, format, looks much better. Any questions so far about how I created these methods? No?
Mm,
All right. So now let's call these methods, okay? Starting from the main. So the user enters in their choice. Let's call our chooser method. So to call a method, all you have to do is type in the name and then pass in your parameters. So I'm trying to call our chooser method. So all I gotta do is type the name, chooser. All right. I spelled it right, chooser. And then our parameters. The first parameter is the user's choice, which is this variable right here. The second parameter is our scanner, which is up here. And we called our method. So what our program will do is go from here, run down these lines of code. When it gets to this line, it's going to jump to here and then run the code that we have in here. All right. So what is case 0 again? What did the user want to do? On case 0, what does the user want to do?
It was Fahrenheit to Celsius.
So what should we do inside this case, inside the switch statement? What should I type here? Well, I want to do Fahrenheit to Celsius, right? I have a method that does that. Fahrenheit to Celsius. So I'm going to call my method Fahrenheit to Celsius, passing in our scanner, right? That method has one parameter, which is a scanner. We pass in our scanner. Case 1, they want to do the inverse. So we have a method that does that. Celsius to Fahrenheit. Passing in our scanner. Case 2, they want to do Celsius to Kelvin. Celsius to Kelvin. Passing in our scanner. Case 3, they want to do Kelvin to Celsius. Pass in our scanner again. And there we go. Our code looks much cleaner, much better organized. So if somebody comes along, they look at your code, they start from the top, they go down to your main. Okay, the main, you're asking the user to do something. You read in that choice. Then you go to a chooser method. Well, here's our chooser method. Depending on that choice, you're either doing Fahrenheit to Celsius. That's obvious because the method name says that. You're doing Celsius to Fahrenheit. Again, that's obvious because the method name. Celsius to Kelvin or Kelvin to Celsius. Otherwise, the user typed in some type of invalid input and we're printing that out. Is everybody following?
Yes, sir.
So
So if I hit enter, our program should run exactly the same as last time. So if I type in some number, invalid input. Run this again. It runs exactly the same. But we know from a programmer's perspective, our program is much cleaner and much more efficient and reusable. We can reuse these methods anywhere in our program if we like. So please enter the value in Celsius. Let's say 50 degrees Celsius, 323.15 degrees Kelvin. Program, again, runs exactly the same, except now we've organized it into methods, which, again, better organizes your program, makes these methods reusable and easier to read from another programmer's perspective. All right, here's a bonus question. What if I want this program to keep running, keep reading in a new value until the user enters in a -1? So they have all these options, and I'm going to put another option. system.out.println -1 exit. How do I keep this program to run over and over again? What should I use? Use a loop, right? A loop goes over and over and over again. All right. So which parts do I want it to loop over? Probably when you read in a new choice, right? And then whatever that choice is, we go to the chooser. So there are several parts of this code I don't want repeated. So for example, I don't want to keep reinitializing a scanner object, so I don't want that repeated. I'm going to put that up here. All right. These prompts, I don't necessarily have to repeat. So whatever parts of my code I want to repeat is what should be inside my loops. So this code, which conversion would you like to do? Reading in their choice, calling our chooser method. That's the code I want repeated over and over again until they enter in a -1. So I'm going to do while true. While true runs indefinitely. It would literally run until your program crashed. Right? So if you are going to use while true, you have to have some type of break statement in this method, in this while loop, that'll stop it eventually. What is our break condition? What do we want to happen for our program to stop?
A -1.
A -1, right. So we have to read in the user's choice first, check if it's -1. If it is, we break our program, we stop it. If it's not a -1, we run the chooser and we go from there. So we read in the user choice, and we want to check if it's a -1. Simple check, we don't really need to use a switch here. If choice equals -1, break. That's it. Our program will stop. And it doesn't reach this line because it breaks outside the while loop and finishes. So if I run this, if I enter in a -1 to start it off, our program just finishes. It stops. It hits this if statement, hits the break, and then ends the while loop. However, if I enter in a number that we're not accounting for, it's going to say invalid input, but repeat which conversion would you like to do, right? It gets down here to invalid input. The chooser method ends. It goes back up here, goes down to the bottom of the while loop and starts over. So we type in a 0. Please enter the value in Fahrenheit, 50 degrees Fahrenheit, 10 degrees Celsius. And you see it repeats again. Which conversion would you like to do? I enter a 2. Please enter the value in Celsius. 80 degrees Celsius, 353.15 degrees Kelvin. Which conversion would you like to do? Let's do a 3. 500 degrees Kelvin is 226 degrees Celsius. Enter in a -1, our program finishes. So now we're making our program more responsive. Instead of user input, this could be a reading from a thermometer somewhere. It automatically converts it. And it repeats every 5 seconds or however long the duration is. So now, again, these are programs that we use every day. So for example, at the weather station, when they are tracking the temperature outside, there is a program that's reading the temperature from those sensors and updating the system every so often. Somebody wrote that program. Why can't it be you? They make a lot of money from writing that very simple program. Obviously, programs get more complex, but you can see the foundation and the tools are now at your disposal to do so. So again, This week, we're going to finish off all of our reviews, and next week, we're going to actually jump into some lectures regarding or referring to this class and the content in this class. If you have any questions, please send me an email, and I'll see you on Wednesday. That will conclude class.
Hey, Professor,